typed your name. So good. So if you're all done, go ahead and pick a notepad. And like I said, I think there might be enough people that can have a notepad. There's an extra one underneath my image there, my video image of myself. If you guys need one, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so I think there maybe is just enough. So just put your name in the top, and that way everybody knows who's who, and nobody will steal your notepad. All right, David, good, very good. So on your notepads, you can change colors, you can change fonts, you can change lots of things. Okay, good. So you guys, I'm gonna go ahead and move on, and then at the very end, like I said, we'll come back, we'll talk about this, and then you'll get an opportunity to go back and post if you didn't post. And then during that time, if you already posted, then you'll be able to leave the webinar and go back to your math studies, the most important, of course, the math studies. All right. Very good, David. Very good. You are on it. Awesome job. Awesome job. Okay. All right, you guys. So today what we're going to do is we are going to solve systems of equations by substitution. So I want to go over that because there are some people that have struggled a little bit with the Khan Academy. Some of you guys have done great and just moved right through it, but it can be a little bit confusing. And then we're going to build and analyze the systems of equations to solve a problem. So as you can tell, we're kind of big on systems of equations right now. And part of the reason is because you are also progressing into linear programming, which is actually very awesome. It's a way of analyzing things. Businesses use it, corporations used it, it was used in the war efforts to figure out, to maximize things like maximizing your profit or determining which product to produce because it would give you the best profits, or how to fit the most amount of different items into a space or something like that. So it's actually a really commonly used thing in business, linear programming. But in order to do linear programming, you guys have to be pretty good at knowing the basics. You have to know how to set systems of equations up. You have to know how to solve them different ways because linear programming uses systems but with inequalities, so it kind of adds a little twist to it. So if you have the foundation, then you'll be really good at linear programming. And linear programming, like I said, it's actually a pretty cool thing. All right, guys. So let us progress into our first thing. So we are going to solve the systems using the systems of equations. So on here, I'm just going to run through a quick mini lesson for you guys. There is one online too. So if you already watched it and you feel pretty comfortable, you don't need to take notes. But if you haven't and you want some extra, modeling of this, do it like this because this will help you a lot. So whenever you're using substitution, think of that word, you guys. Substitution just means that you are substituting something in for something else. So if you look at this first equation or set of equations, right, these are both linear equations. If I were to graph them, they would make two lines, and most likely the lines will intersect. So whenever we say we're solving systems using substitution, we're looking to find where they intersect. Okay, so our first equation is not in y equals mx plus b form. This is actually a standard type form, and that's okay. Our second one is actually y equals mx plus b form. But really, when we're using substitution, all we're looking for is one of the equations to say y equals or x equals. Because if we know what y equals, I can make a box around this. And then it doesn't really matter what's in that box. I just know that wherever I see a y, that's what y is. So if I look at my top equation, I have 2 times y, right? Well, I can take this 5x plus 6, and I'm going to draw a little arrow over here, and I'm going to change y out and put 5x plus 6 in there because that's what y is. Okay, and our goal here is just to have one variable because you guys have had a lot of practices now where you're evaluating and simplifying and solving equations with one variable, but it's pretty hard to solve an equation with 2 variables. I mean, it's really just rewriting. So what I'm going to do now is I'm going to take this top equation, and if you guys have any questions during this, feel free to put them in the chat because I can still see your chat. So if you need me to stop or explain something, please tell me. So we've got 2 here. I'm going to leave the 2 there, but now instead of y, and I'm going to use parentheses because I'm going to put this whole expression in here, 5x plus 6. Okay, so that is now going where the y is. And then I'm going to leave everything else the same, right? So what did I do? I substituted. Okay, I substituted the 5x plus 6 in place of the y is all I did. So look what I have now, you guys. I have an equation that only has x's in it. That's perfect because I know how to distribute and combine like terms and solve for x. So that's exactly what I'm going to do now. So I'm going to take the 2 and I'm going to distribute it into the parentheses in order to get rid of the parentheses. So 2 times 5 will give me my 10x, and 2 times 6 gives me 12. Okay, and then I'm just going to write everything else I have. And I've seen that you guys are actually really good about writing out everything. It's nice. You don't skip a lot of steps, so then you're less likely to make mistakes. So now I'm going to combine like terms on the same side. Well, I have a 10x and I have a negative 7x. So I need to combine those. So 10x minus 7x gives me 3x. So I have 3x plus 12 now equals 9. And now I'm going to combine the 12 and the 9. But in order to do that, I have to subtract 12 from both sides. Okay, and now I can write what I have again. So I have 3x remaining on the left side. 12 minus 12 is gone. And 9 minus 12 gives me a negative 3, right? Yes, mental math. Okay, and so now I'm going to solve for x. And in order to do that, all I have to do is divide both sides by 3. 3 divided by 3 is 1, or 1x. And negative 3 divided by 3 is negative 1. So if we think about what I just found the x-coordinate of where the two lines intersect, right? So I have one line that, and I'm just going to do kind of an example, that maybe looks like this if you were to graph it, right? And then I might have another line, and I'll do it in a different color, that if I were to graph it, maybe it looks like that, and I'm just guessing. When it says solve the systems, I'm looking for this solution where they intersect. So I have now found the x-coordinate of that point. That x-coordinate is negative 1. So what I'm missing is the y-coordinate. But if you think about it, it's going to be really easy to find because if I know the x-coordinate, I could plug it into either one of these equations and solve to figure out what y is. And it doesn't matter which equation because y will be the same in either equation. This is the point where they intersect, so x and y are the same. So I'm going to use my second equation here, this y equals one. Just because that one is already solved for y, so it'll be easier. So I have y equals 5. I'm going to substitute in negative 1 for x plus 6. And this will be very short. So y is going to be equal to negative 5. 5 times negative 1 is negative 5 plus 6. So y is equal to 1. Negative 5 plus 6 is 1. So the coordinates are negative 1 comma 1. Okay, so I have solved the system using substitution. And one thing you can do is you can take those points and you can plug them in to each one and make sure that the left side equals the right side. So if I plugged in a 1 for y and a negative 1 for x on the left side, I should simplify it and get 9. Okay, and if I plug in a 1 for y on the bottom equation and a negative 1 for x on the bottom equation, I should get 1 equals 1 when I simplify, and I will. Okay, so I could do that, but it's just something for you guys to do if you're checking yourself in a test or a quiz to make sure you got the right solution. Okay. All right, you guys. Any questions on the first one at all? You guys are all good? Very good. Okay. So what I'm going to do is I'm just going to do one more just to make sure you guys are feeling pretty good about this, and then we are going to work together on creating some systems together, kind of like we did last time. And then we'll finish by going back over you guys' discussion. And if you have any questions on anything, you can ask me too. Anything. Okay. All right, you guys, so second one here. Second one, final one of these. So again, we have a y equals. I could have an x equals. It wouldn't matter. But the key is to box what that variable equals because that is going to substitute in for y in the other one. Okay? So this one, you just have to be careful because on this one, I have a negative in front of the y. I still need that negative. So I have to be careful to always put what I'm substituting in parentheses, okay, so I don't mess up signs or anything else. Okay, and then when I simplify, the key here, and this is where everybody always messes up, this negative in front is really a -1. So I'm going to write in a 1. And that sometimes helps you guys to see what you have to do. So you have to distribute the -1 into the parentheses. -1 times -3 is a positive 3x. -1 times 6 is a -6. So you just got to be careful about that. If you just put the -3x plus 6 here and you don't do parentheses, inevitably what happens is you mess up your signs. Okay. So Samantha, good, I see you typing, so I'll pay attention if you're asking me a question. So now what I'm going to do is I'm going to, oh, you have a puppy, a little puppy. Okay, that's fine. Just come back, and then whatever you miss you can watch, and I will record it too for you. Okay, so what I'm going to do is solve for x. So I'm going to subtract 3x, move it to the other side. I'm combining like terms, basically. 4x minus 3x is just 1x. Okay, and then these are gone. 3x minus 3x is 0. I'm going to combine -6 plus 1 to give me -5. Okay, so that's what x is. Now I'm ready to substitute. So we'll use another color. So I'm going to put a -5 in for x. And again, you guys, I'm just going to use the top equation because the top equation already is in the form of y equals, so it's a lot easier to simplify. But I could use the bottom equation if I want to. All right, so y is going to equal -3 times -5 is positive 15. And positive 15 plus 6 is positive 21. Okay, so one thing too is that I'll usually ask you guys to write your answer as an ordered pair. So what that means is I would write my answer as -5, oops, another post, as -5, comma 21. Okay, and that would be my answer. Just like on this top one, I wrote it as -1, comma 1. On this bottom one, or the one to the right, I should say, it's -5, 21. All right, you guys, so that's your quick lesson on substitution. How do you guys feel? You guys are good? Emily, how about you? Yes, you did actually take very good notes. This is good. And I know, Emma, you're good because we went over this together. All right, so David or Donovan, if you guys have any questions, I know Sam just went out. Let me know how you feel. Oh, Sam, you're back. Oh, good. Yeah, David, and so you understand, good. So Donovan, how about you? How are you doing? And Emma, you're good too. Awesome. All right, you guys, so good. All right, you guys, good. And remember, when you're doing your Khan Academy practices, like I said, if you can't get, these only require you to get 3 in a row. And if you can't get 3 in a row, it's not a huge deal, but don't just only try 3 or only try 4. You know, try a few more if you're not getting them in a row and use the hints to help you. I mean, I can still go in and see your effort, and I'll just, oh, really? And I'll grade you on your effort. So, you know, again, not a huge deal if you guys are not getting the 3 in a row. You know, obviously I want you to try hard to do that, but if you can't do it, it's, like I said, not a huge deal. Okay, so guys, let's actually do our interactive part here together. This is our togetherness. So here we go. Okay. So in your note pods, you guys, you're gonna do this problem. So I'll kind of start you off. These two guys, Bill and Steve, they spend the afternoon at an amusement park enjoying their favorite activities. So they have a water slide, oh, and the Ferris wheel, and it's not spelled correctly. And that's what they like to do. It's a ginormous Ferris wheel, and that's why they like it so much. There, not spelled correct. Their tickets are stamped each time they slide or ride. And, wow, there's, you know what, Jasmine, yeah, problem, I have problems. It's not you, it's me. At the end of the afternoon, they have the following tickets. Okay, so this is how they were stamped. So Bill's came to a total of $17.70. He rode the water slide 3 times and the Ferris wheel 3 times. Steve at the end had to pay $15.55. He only rode the water slide twice and the Ferris wheel 3 times. So ultimately what we're trying to do is determine how much it costs to ride the water slide and how much it costs to ride the Ferris wheel, and that's what you guys are trying to figure out. So in your notepads to start off with, though, I want you to define your variables. So what are your unknowns? Is it number of hot dogs? Obviously not, because we're working with Ferris wheels. But what is it? What are your 2 unknowns? What are you trying to find? So do that as number 1 in your notepads. And then number 2, see if you can, to the best of your ability, write a systems of equations. So you're going to write 1 linear equation for Bill's situation and 1 for Steve. So start off with that. I'm going to grab my power cord while you guys are doing that. I'll be right back. I'm about to die. Computer's about to die. Okay, I'm back. So, hopefully you guys are all doing good. Holy moly, almost out of disk space.
With these three good equations, y equals 15.55 divided by 5x and y equals 17.70 divided by 6x.
So think about your linear equations. They're usually going to be linear. When you divide by an x, you're creating a rational type equation. So you probably won't have anything where you divide by x if you think about it. But it's okay. I mean, do what you think logically, because a lot of times what you're thinking will lead into exactly the right. So think about it a little bit more if you want, Jasmine, and we will do these actually. But yeah, sometimes it's kind of hard to think about it. Okay, so it looks like you guys have your variables defined. Emma, you're kind of confused. Okay, so it looks like, so we'll kind of talk about what to do next. But let me look at your variables first. So the cost of the water slide and the Ferris wheel, those are going to be your variables too. So your W will be the cost of the water slide and the F will be the cost of Ferris wheel. So that's perfect. So it looks like Emma, Jasmine, David, good. So Samantha, it looks like you were just trying to guess on what the prices are already. So before you even get to that point, you want to always define your variables, like, what is your x going to be, what is your y going to be, or you can define it as W is the cost of the water slide, or you could even say x is the cost of the water slide, and Emily says the cost is good. You guys are on the right track as far as defining your variables. So what your goal is to come up with some kind of linear equation, right? And normally they're in the form of y equals mx plus b, but they could be in standard form like 2x plus 3b or 2x plus 3y equals 20 or something like that. And that is actually going to be more similar to what you guys are going to use here actually in this. So they're not always going to be in the y equals mx plus b form. So good, Sam, good. So you've got cost of water slide and then the cost of the Ferris wheel, perfect. So you've defined your variables as WS and FW, which is fine. And then probably for your equation, you'll just want to use W and F. So Emma, good, you're on the right track. I think you're definitely on the right track. You guys are getting there. much stuff open here. Okay. So, good. Okay, so Emma, you are totally on the right track, but you wouldn't need a y equals because you've already got your two variables in your equation. But your equation looks actually really good, just so you know. Perfect. Jasmine is also going strong here. David is also good. Emily's in deep thought. She's deeply thinking. Okay, and you guys, these are good too because when we start to do our linear programming this week and next week, you will start to see that you have to be pretty good at turning words into equations because you have to write things called constraints, which are your inequalities. So the better you are at it, then the easier it'll all be for you. All right. Awesome job. All right, David. Very good. Very good. Very good. Jasmine, nice job. So you figured out. Good. And Emma, on the right track. Awesome. All right, Emily, you're thinking, I know. Donovan, you're hiding. I know you're there. You have not taken your note pod. I see you. Oh, I know, Donovan. You said you had to go and take. Was that you? Had to go take a dog out? No. Oh, that was somebody else. Who was that? Who had to take their dog? Oh, that was Sam. Sam. It's your. Never mind. I remember that was you. Donovan, where are you? Oh, you didn't know one was yours. Of course one is yours. You always get one. I know, Donovan, I forgot you didn't have a dog you were taking out, but I know you have lots of dogs because we've talked about your dogs before. But I remember now that Sam had to take her dogs out. See, there you go, Donovan. Awesome. All right, you guys. Well, it looks like most of you guys are totally on the right track here. So I think we're going to go ahead and just get started just for time's sake. But nice job. You guys are doing a really good job. So if you're not sure what this is, kind of think about this. And that way it'll help you when you start to do your problems in your practices. Okay, so if we take these individually, first of all, defining your variables, it's always what you're looking for. And you can see when you look at the questions down here and it says how much does it cost to ride the water slide, well, that is one thing you're looking for, right? The cost of the water slide. And some of you guys, and we'll just define it like you guys did, you said that would be W. And then the cost of the Ferris wheel, most of you guys said F or some form of that. So we can do W and F. You can also do X and Y, either one. So we have defined our variables. And that will just help you when you're writing your systems of equations. So when we're looking at writing our systems of equations, we do each of these situations separately. And you guys are right on, right? You said that there were 3 water slide tickets, right? At what cost? We don't know. Maybe it was $2. Maybe it was, Samantha was guessing earlier that it was, or she put down $2.15. She could be exactly right, but we'll have to check and see. So that's W though. Whatever it costs, we called that W. And then plus we have to add to that 3 Ferris wheel rides at a cost of F. We don't know, but we know that he paid a total of $17.70. So nice job, you guys. You were totally awesome with that. And then we do the same thing for Steve, right? So he only rode the water slide twice, and he did ride the Ferris wheel 3 times. He must have loved the Ferris wheel. And he paid, they all were 3 times on the Ferris wheel. And he paid $15.55. So you guys, here's where you win, right? If you can come up with 2 great equations, then you can always solve that system because you have multiple things in your toolbox. You know how to graph, to solve by graphing. You know how to solve by substitution. And if you guys have gotten to it, I know, Emma, you did, and I'm trying to think of, Jasmine, did you get to the substitution? I thought some of you guys did.
I'm only on week 9.
Oh, never mind, you didn't then. Some other people. So a couple of you, so I think most of you guys have not got to substitution, but that's another way to solve this. So actually maybe we should solve it by substitution just so everybody can see how to do that. So the key though is making these equations because then you can solve them. Okay, and again, you can always fall back on graphing. All right, so we have our 2 equations, which aren't written down here, so I'm going to have to write them down again. But anyway, we have a 3W plus 3f, we said, equals 1770. And you guys do know how to do substitution, and we did just do substitution, but I think this one's going to be easier to do something called elimination. So I'm going to show you that because we don't have to do much work for that. So if you have an equation that's set up like this, where there is no variable like w equals or f equals, we can do something called elimination. So with elimination, what we can do is we can just add these all together or subtract these, and then we can come up with an answer. And that's a simple elimination. So what I'm going to do, if I look at 3w minus 2w, I get 1w. I still have a w. That doesn't eliminate my w's. But if I take 3f minus 3f, what happens to my f's? They're gone, which is what I want, right? Because I can't solve an equation with two variables. So I think I will subtract these. Sometimes you can add them, but in this case I'm going to subtract them. So what I'm going to do is I'm just going to subtract these from each other. So 3w minus 2w leaves 1w. 3f minus 3f, well, that's gone. And 1770 minus 1555 is some number that I don't know, but I'm going to do some mental math here. I think that's $2.15, which, oh, Samantha, nice job. $2.15. You already solved it. Good job. Woo! Very good. So that's how much it costs to ride the water slide. So that was pretty simple compared to the substitution. And so this is called simple elimination, when you can add them together or subtract them to get rid of, to eliminate essentially one of the variables. So now we need to know what the cost of riding the Ferris wheel is. Well, we already know we have two equations, and if we know w, we can just substitute it in for any of these. So I'm going to go ahead and use the bottom equation. So I'm going to say 2 times $2.15 plus 3f equals $15.55. So essentially, you're really using substitution after you do elimination once. So 2 times $2.15 gives me $4.30 plus 3f equals $15.55, dealing with all this money change. And if I subtract $4.30 from both sides, then I'm left with 3f equals $11.25, right? I think I added right. And then if I divide both sides by 3, so I'm just solving a linear equation, which you guys are really used to. 3 divided by 3 is 1f, so our f. And 11.25 divided by 3 is, let's see, 3, 6, 9, 10, 11, 7, 5. $3.75. And that's what Sam has, so I must be in good shape. Oh, David, that's what you have too. Good job, you guys. Good job. So that's one way to solve a systems of equations using elimination. And the key for you guys is setting them up. But y'all, very nice job of setting it up. All right. Any questions on that? Any questions? Emma, no. No, no, no. Okay. And, all right. Donovan, how do you feel about that? Were you good with that? I know you're not quite to systems yet, so some of this might be a little bit brain overload because if you haven't gotten to the systems at all or seen them, and I don't think you were in the last webinar where we did some systems either, so it might be a little bit too much in the short-term memory, I guess is a good way of describing it. Okay. So, and it'll help you too, Donovan, to see this and then actually watch the lessons because then you'll say, oh, okay, I know what Miss Elliott's talking about. All right, good. All right, guys, well, let's actually move on then to go back to our discussion. Or not, because it's frozen. And there's the answers again for all of you guys, $2.50. Okay, so here was our webinar discussion prompt, and we'll actually see if I can see what you guys said on your discussions, perhaps, if the internet will allow me to. And really, in a situation like this, anytime you have two things, your mind should always think, hey, systems of equations, systems of equations. So, Jasmine, you just went with the 5. No explanation. Oh, wait.
I did.
Oh, you did below. Okay. I'm like, you just kept 5 all of a sudden after all that work. But no, I see your work. I see your work. So, so you put in an equation. Good. Good. Okay. And then Emily, I see what you did. Very nice. So you were in the process of solving it. Emma, after 5 hours, because you did. So Emma, were you guessing on the 5 hours? Or, I mean, did you do like a plug and check? Or, because I don't know how you know to get 5. I can see you're typing, so I'm going to keep looking. And then David, you did one of the, okay, good. And David, you're actually, okay, no, you didn't. So Emma, how did you get 5? Did you do a systems kind of like this? So David, you are good because you're using your X's in the right place. You have, so Jasmine, you used Y's and you're really close. And I'll kind of explain where you are, but you're on the right, totally right track, totally right track. And again, you can use whatever variable you want, but usually if you use your Y's and X's, put your X's with the rate of change. So Emily, you're good. You put your X's with the rate of change. You just have one little thing, but you have 5. So I don't know, some of you guys have 5 maybe because if you looked back, I don't know if you looked back and saw the 5 and they're like, how's that going to work? Did you look back and see 5? You actually did come up with the 5? Oh, very good, very good. So Emma, I know you're still typing. Oh, wow, Emma, you have this whole long explanation. Oh, and you kept subtracting until you eventually got down to, okay, good. Emma, that's totally fine. That's good. That's why I was kind of curious how you did it. It took 5 times to subtract. So perfect. So Emma, you did kind of more of like a table approach where you just kept subtracting. You started with the starting amount and you subtracted each time. So that's awesome, Emma. That's totally awesome. And then it looks like a lot of you guys did a table, or not a table, and systems of equations, which is perfect, which is what I wanted you guys to do. So, and let's kind of look at this situation real quick, and then I'll let you guys go back in and do some posts if you hadn't done it already. But some of you guys I've noticed already did, so you guys are very proactive. So if we take each of these separately, just like we did with the Ferris wheels, think about your equations. In this case, we have y equals our slope is our burn rate, right? So the taller one burns at 1.15 inches. So it's burning, and this kind of we were talking about, Jasmine's, that it's burning, so it's going smaller, right? So this is how much it burns. So it's negative 1.15 x, and then our starting height for the big one was 9 inches, right? So you can make an equation to model how much each candle burns. So if we started at 9, we lose 1.15 inches every hour, right? It like goes down, which Emma is kind of what you did with the table. You just decreased it by 1.15 each time. And then the other one starts at 7 and it loses 0.75 inches every hour. So you can make another equation. And again, you guys, once you have 2 equations, you can find what x and y is. You could throw these into a graph, which is what Jasmine was trying to do, which is perfect. Totally could do that because they're in the y equals mx plus b form, very easy to graph. Or like David, I could see that you were solving using a system of equations, and a couple of you guys, I think, actually, Emily, you were doing that too, solving using the systems, and you just didn't have a negative on one of them, but it looks like you probably knew it was negative, you just didn't type it in. So anytime you have a y equals, remember that you can substitute. So I can take all of what y equals right here, and I can substitute it in for y right there. And so then this is what I saw on you guys' equations, right? So I saw this negative 0.75 plus 7 on one side, and you set it equal to negative 1.15 x. Oops, where's my x? There's my x. Plus 9 on the other side. So I just substituted this square in for y, because that's what y is, and I get this. And so when you guys were simplifying it, you just combined your x terms, right? You added 1.15, I should say, x to both sides. So what does that equal? Is that 0.4? 25, 35, yeah, I think so. 0.4x plus 7 equals 9. So a little bit of solving to do, but that's what you guys did, and you got the answers you got, which is exactly right. So if you take, we'll scroll up here, 0.4x equals 2, and you divide by 0.4, then you get x equals 5. So that means that it takes 5 hours for them to equal the same height. Okay, so let me ask you guys this question to finish off. If I said to you guys, based on this, okay, so after 5 hours they'll be the same height, how could you figure out how tall they were going to be? Thoughtful question. Emily's smiling. So anybody who knows, feel free to use the chat as much as you want.
All you gotta do is they decrease at, what did Emma say, 1 point?
Oh, well, the tall one decreases at 1.15 every hour, and the small one decreases at 0.75 every hour.
So after 5 hours, so 9.
Jasmine's doing a calculation. What we're trying to do is figure out how tall they would be. How tall they would be. So how tall would the candles be after 5 hours? What could you guys do?
You just gotta find out how much inches they decrease after every hour, how many inches they decrease.
Okay, good. So Jasmine's thinking of like the Emma way. She would just subtract the 1.15 5 times from the 9. You could do that. How could you use these equations, you guys? Could you use one of your equations to figure out?
9 minus 1.15 divided by 5.
So think about, what does y represent in this equation? What does y represent?
The unknown.
Yes, what unknown?
How tall the candle would be after 5.
So y represents how tall the candle would be. So if you're trying to figure out how tall the candle would be,
5.
then where would you put the 5 into the equation? For y or for x? Y is how tall it's going to be, Emily, for x.
5x divided by 1.15.
So Jasmine, think about, so David's got it. Yep, that's exactly right. So think about your equation. You're not changing. Once you have your equations, use your equations. Like, don't add divisions, don't add subtractions. That's your equation. So if you know that the candles are going to be the same height after 5 hours, think about how we just solved those systems. You know what x is, right? So what you're trying to find is y. So to figure out y, if you plug a 5 into the top equation or the bottom equation, doesn't even matter. If you plug that 5 in, it'll tell you how tall the candle will be when they are the same height. So that's why it doesn't matter which equation you guys use.
So y equals 5x minus 9, y equals 5x minus 7.
Well, no, y equals one of your equations. So like y equals negative 0.75 times 5, right? You're plugging that 5 in for x. So if you plug that 5 in for x and you solve for y, you'll figure out the height. Okay. So if I'm looking, like if you guys are looking at the at this, so let's just say I write on here. So say I want to find the height, right? So I can choose either the top one or the bottom one. So negative 0.75, plug a 5 in, I'm going to do the bottom one, plus 7, then whatever that is, what is that, 25 carry the 2, 3, 5, 6, 7, maybe I think that's 3.75 plus 7. And if I take 7 minus 3.75, what do I get, like 3¼ inches tall or something. So, I mean, you know, assuming that I did my math right, that's how tall the candle would be. So good, David, that's exactly, very nice. All right, you guys, so just kind of finishing off, go ahead and go back to your discussion, and if you didn't post a reply to somebody or a question, or you can post something you learned from this as well, but go ahead and finish off with that, and that concludes our webinar. So any questions that you have before you go, post them in the chat. Otherwise, I'm going to end. Bye, Emma. All right, Donovan, I see you typing. All right. Bye, Samantha. Donovan, tomorrow I'll be at Gateway, and then I'll be at Central Thursday, actually. Bye, David. It's good having you. All right, Donovan, we'll see you guys. Good job. Very difficult stuff sometimes. Sure.